welcome to part 2 of the how to build an NXOS 9000V based EVPN VXLAN fabric. We'll work on the L2 bridging and L3 routing. With the EVPN VXLAN fabric built, we can now turn our attention to the configuration required to perform L2 bridging, which is the L2 VNI and L3 routing L3 VNI from our hostnet. For VNI number and further clarity on how our topology will look once configured, you will see the configure in this diagram. Once configured, the traffic flows intra VNI and intra VNI will look like this diagram. Okay. First is L2 bridging. L2 bridging, aka the bridging of traffic L2 frames between end hosts on the same VNI will be achieved via the L2 VNI. We'll be working on NXOS 3 and on NXOS 5. Logging to my NXOS 3. We'll first say fabric forwarding and cast gateway MAC address 000, 0011, 1234. We'll create a VLAN 10. VN segment ID is what? It's 100. It's 1010. Put it in there. Interface VLAN 10. No shutdown. IP address 10.10.1.254/24. We'll say fabric forwarding mode is Anycast gateway. Next, we'll go to interface MVE1. Show run interface MVE1. We have credits right here, but we're gonna to say member VNI 1010. We'll suppress ARP table MCAS group 224.1.1.192. Okay, that's done. So interface MVE1, this is what we have. Next, we're going to say EVPN VNI 1010 is L2 VNI. RD, say auto. Route targets, we say import auto. Route targets, exports, we say auto. Show run BGP to the end, you will see this config right here. Okay, logging next to NXOS 5, leave 5. Okay, we'll do the same thing. Fabric forwarding Anycast gateway 000, 0011, 1234. VLAN 10, again, VN segment that's only required for my VLAN 10 L2 VNI is 1010. Okay, that's 1010. Next, interface VLAN 10. No shut. Okay, IP address 10.10.1.254/24. We say fabric forwarding mode Anycast gateway. Interface MVE1. I will show what we have right now. It's like this, with just source IP and the host reachability protocol using EVPN BGP. Okay, we'll create a member VNI 1010. Suppress the ARP MCAS 224.1.1.192. EVPN, same thing, RD auto. RD will say auto. It doesn't let me to enter commands, so I paste all these features where required. For now, you don't worry about this, just EVPN VNI 1010 L2. we say RD auto. Here you go. Route target, both auto. So run BGP. Here you go. In the end, we see our config. The next will be taking care of the next VNI, L2 VNI is NXOS 4 and 6. We're taking care of L2 VNI 1020. That's my VLAN 20. Okay, this is my VLAN 10. Now, same thing to NXOS 4 log on to it. What we'll do, config T will be fabric forwarding anycast MAC 0000011.1234. Same thing, 20, VLAN 20, VLAN segment 1020. Interface VLAN 20, no shut, IP address 10.20.1.254/24. Fabric, forwarding mode, anycast gateway. Interface MVE1, member 1020. Okay, MCAST, member, say VNI 1020. Suppress the ARP, MCAST group 224.1.1.192. Okay, same thing, same MAC address, same MCAS group for VLAN 10 and 20, member BNI 1010 and 1020. No worry about that. EVPN, BNI this time is 1020, is L2, RD auto, route target, say both, auto. Show run BGP, show run interface MVE1. Here you go. We'll be creating VLAN 20 and VNE interface member 1010 and EVPN RT. Okay, now go to next NSOS 6, leave 6, then create the same thing. Fabric forwarding anycast gateway MAC address 00000111234. VLAN 20 VLAN segment 1020, interface VLAN 20, that's no shuttered, IP address 10.20.1.254/24. Fabric forwarding mode is anycast gateway, interface MVE1, show run interface. Let's take a look. MVE1, same thing. Member MVI VNI 1020, suppressed ARP, MCAS group 224.1.1.192. EVPN VNI 1020 L2. RD is auto, route target RT, both auto. Show run interface VNE1, show run BGP. Here you go. Then we're going to validate all of that. Let's validate my leaf 1, which is leaf 3, NSOS 3. To validate, we can view the EVPN routes learned against one of L2 VNIs. Once done, we can check connectivity. So show BGP L2 VPN, EVPN, VN ID is 1010. We don't see anything yet. What we'll do, we'll log into server 1 and server 3 and do a ping. Okay. Server 1, server 3. We're gonna ping 10.10.1.254. Take a look here, we'll not be able to ping. That's because we have to go to my interface, show run interface E13. Okay, In the host connected ports, E13 was a switch mode access, switch access, VLAN, that's 10. Okay, no chat, same thing. Let's go to the NXOS 4, again, interface, E13. Take a look at diagram here. It's supposed to be 20, is 10, 10, 20. Okay, okay. So switch mode access, switch mode access, switch access VLAN 20. Okay. Interface E13, switch mode access, switch mode access, switch access VLAN 10. NXOS 6, interface E13, switch mode access, switch mode access, switch access VLAN 20. Okay, let's go to server 3 and ping the gateway again. Yes. Server 1, ping the gateway again. Let's see what's the gateway. Okay, 10.10.1.254. Hello. Okay, so let's go to NXOS 3. Then we'll do once we do a show again. Remember the show command. That's show BGP L2 VPN EVPN with specific VN ID 1010. Here you go. We're going to see each one's loopback interface, VTAP 3. VTAP is the leaf 3 and the leaf 5 here. Now go to the server 1. I can to go to ping. We're going to make a ping packet from server 1 to server 5. Okay, ping is successful. Show that command again. I can also show MVE peer details. We can see one detail. That's my NXOS 5. Okay. Show MAC address table. We could see for the remote host, we can see it's going to the MV interface. For the remote host, its intra VLAN communication is successful. To see what exactly the VNID is hosting in this NXOS 4, we can show MVE internal platform interface MVE1 detail. Here you go, is MVE1 status up, and we are hosting an L2 VNI. VNID 1010 is actually saying show VXLAN command. Just showing you. Okay, only one L2 VNI. Logging again to server 2 and server 4. Move a little bit here. Server 2, we could ping 10.20.1.254. Yes. .2. Yes. Go to my NS5. I'm okay to ping from here to here. Log into NS OS4. Could see show MAC address table. Same thing, you can see a remote host intra VLAN is located in the peer MVE. Okay, we have a peer. Same thing for VNI 1020 for VLAN 20. One thing I want to show you is a show run. Remember, we created the MAC address, anycast MAC address. It is gonna change for my server. So show MAC. So show in the host one, server one, just say up. Up table showing the remote host. My gateway IP is 0000100111234. Exactly is changed for the anycast gateway MAC address. So it doesn't matter which, if the host moving to the other host, because the MAC is the same. It's gonna be seamlessly go to anywhere without a problem for communicating with the gateway. At this point, in order to forward traffic between VNIs, we have VNI 1010 and 1020. We create them intra VNIs communication for L2 VNI between L2 VNI needed an L3 VNI. So we will configure an L3 VNI for traffic to communicate each other between the VNIs. The traffic will be routed to the L3 VNI within the leaf when destined to other VNI. The packets will then be sent bridged over the L3 VNI to the remote node, where the traffic will again be routed to destination VNI. In other words, the traffic is routed, bridged, then routed. Okay. So what I mean is the traffic sent here to my local VTAP, then this will be routed, routed here, and will be bridged and be routed. This snippet shows an example of a captured packet from one of the leaf to spine uplink. You can see the packet is sent over to the L3 VNI. VNID shows here is 100,999. This is the VNID inside my VXLAN header. And VXLAN use UDP 4792. This is how the entire packet construct in VXLAN. And take a look here. What the packet is it? Type 0, code 0 is an ICMP packet. Okay, just a side note. We'll give to a configuration to the inter VNI routing. Okay, so let's log in to the diagram and we'll be configuring it. To all leaves, will be configure is VLAN 999, create a VN segment 100,999. Okay, and we're creating VRF. Everything will be within a VRF. We say tenant we say VF content tenant. Okay, VNI 100,999. RD say is auto. Address family IPv4 unicast. Route target we say both. Auto EVPN. Creating a VLAN interface 999 no shut is SVI interface member say VRF member, one member is tenant 1, IP forward, show run interface MVE1. We don't have an L3 VNI, so interface MVE1 member VNI 100.999 associated VF. Now show run interface MVE1. This is what we are configured in MV interface. Configuration will be applied to all my leaves. Go to leaf 4. I don't want to waste time. Let's just paste all the config here. NXOS 5. Paste for my L3 VNI. NXOS 6. Paste all that. Okay, now go to server 1 and ping 10.20. Say we want to ping from my server 1 to server 2. So the server 2 is server 1, crossing an L3 VNI. It will be routed. Okay, let's see. Let's see the traffic is not able to ping it, and ping .2 still no. Okay, what could be go wrong? So logging to NXOS 3, what we'll be doing is show run BGP. Do we have a route to VLAN 20, VLAN 10? No, we don't. Okay, what we'll be doing is router BGP 64520. We're creating this VRF tenant 1 log neighbor change address family IPv4 unicast. Okay, we're network 10.10.1.0, my local VLAN 10 subnet, and advertise it L2 VPN, advertise L2 VPN, EVPN. Okay, this command doesn't exist, then let's just show run BGP. We have an tenant 1 and advertise my local route. Okay, let's do the same thing to NXOS 5. Go to NXOS 4. We'll do the same thing. I'll advertise VLAN 20 subnet. NXOS 6. Also do the same thing. So run BGP. Now go to NXOS 3. Show run interface VLAN 10. What we'll do when interface VLAN 10 and VRF member is tenant 1. IP will be gone. Paste again. Show run interface VLAN 10. Here you go. Copy this to my NXOS 5. Go to NX 4. Show run interface VLAN 20. Same thing. Interface VLAN 20. VRF member tenant 1. Copy paste the IP again. VLAN 20. Copy paste to NXOS 6. Now we'll do a test and ping. Make this ping again, and we'll make a ping to. Wait a second. We're gonna make a ping to server 3 also. Server 2. server 3, server 4. We'll make these all ping to 3 servers. Okay, so let's verify 10.20.1.1 on server 1. Yes, to the same VNI server. I believe that's server 3. Server 3 we already tested, it's fine. And server 4. Here you go. We verified by testing pinging, and to validate, we can see the EVPN routes learns against the L3 VNI. On NXOS 3, show BGP L2 VPN EVPN VNID 100.999. Here you go. We successfully find out for the VTAP, NXOS 4, NXOS 6. Showing one more time. Here, in VNID 1010, the local VNID, we know ourselves for sure. NXOS 5, both are discovered. VNID 1020, we discovered NXOS 4 and 6. These are the loopback interface. A host route, these we're showing the L3 VNI, so these are the routed routes, right? It can be routable. So these are 10.20.1.1, 10.20.1.2. They are remote VTAPs, okay? So you remember this number 5252. What is the 5? The 5 stands for type 5 EVPN route. Type 5 is an IP prefix route. See, there's a prefix, right? /24 is a prefix route. And what does 2 stand for? 2 stand for a MAC IP advertisement route. EVPN type 2. Okay, this is a type 2 route. Type 2 route is also called MAC IP advertisement route, I told you. They are used by the VTAP to advertise the host IP and MAC address information to each other. The 2 most known VXLAN types route. The prefix type 5, EVPN type 5 route is for what? For IP prefix route. They are used to transmit the network segment route. The difference from the type 2 routes that transmit only /32 bits or 128 bits IPv6 host route. The type 5 route can transmit network segment lengths ranging from 0 to 32 or 0 from to 128. So these are the difference. So here we made it. As you can see, there's a lot of config with many layers and protocols to take into account. I hope you enjoy this tutorial, and you can find all my VXLAN EVPN labs in my channel. Thank you for watching.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.